Algebra 1 students, welcome to your 9.5 notes, Completing the Square. Today we're going to look at a new method for solving quadratics. Remember, we've already looked at how we can solve by factoring. We've looked at how we can solve by graphing. We've looked at how we can solve by using the square root method. We have a couple methods to go. Today's again is called completing the square. So the nice thing about completing the square, and this is mentioned in the big idea box, is that any quadratic equation can be solved by creating a perfect square trinomial on one side. Now I will tell you, even though all can be solved using completing the square, some people would say that some equations are better suited than others to using this method. I would argue it's a pretty good method just about all the time. Alright, so I'm going to walk through this example with you. This one's already worked all the way through. We started with x squared minus 8x equals negative 3. Now this number 8 right here, and again I'm kind of ignoring the negative, but this number 8 is key. It's our b value. Again, technically it's negative 8, but that's okay. We don't have to worry about the negative. So what we do in order to complete the square is we take that b value and we divide it by 2 and square it. So 8 divided by 2 is 4, and 4 squared is 16. We add that to both sides of the equation. It's always added. It's always the same number on both sides. Now you'll notice over here I wrote 4 squared. Over here I wrote 16. Those are the same things. I did this on purpose because what happens is we're creating a perfect square trinomial. X squared minus 8x plus 16 is the same as x minus 4 quantity squared. And then you could just kind of simplify the right hand side, and then we can use our square root method. The square root of both sides gives us plus or minus the square root of 13 is equal to x minus 4, and then we add 4 to both sides and we're finished. Now you can see the approximations here as well. But the big picture is, if you have a 1 lead coefficient, if a is 1, then you can complete the square by just doing b divided by 2, squaring it, and adding it to both sides. So we're going to get plenty of practice on that. I know it seems maybe a little bit out there right now, but don't worry. We'll get that fixed as we move forward. So on the first problem, it says x squared plus 6x plus c, and we want to find a value for c that creates a perfect square trinomial. So what we would do in this problem is just take 6 divided by 2. That's our b value, right? And square it. Well, that's 3 squared, and so that's 9, and we know that's our value for c. And by the way, it didn't ask us to do this, but if it did, we would know x squared plus 6x plus 9 is exactly the same as x plus 3 quantity squared. So that's the idea. We're trying to create a perfect square trinomial. On number 2, same kind of problem, 22 divided by 2 quantity squared. Well, that's 11 squared, so 121 is our value for c. And then number 3, the same kind of deal. The only thing that might complicate it here for you is that you have an odd number for b, so it doesn't work out quite as pretty, but still we can square it. 3 halves squared is 9 fourths, and that would be our c value. All right, let's go ahead and do some solving by completing the square. We've seen how to create a perfect square trinomial, but this is the reason that we do this. All right, so far we've just done a little practice. We haven't actually looked at why we do this or how it works, so we're going to change that. All right, so x squared plus 16x equals 17. First thing I'm looking at here is the b value, which is 16. So I know b is equal to 16, and 16 divided by 2 is, of course, 8. So we're going to add 8 squared to both sides. So I'm going to write it this way: x squared plus 16x plus, and I'm going to put 8 squared right here, is equal to 17 plus, and now you guys know what 8 squared is. We can go ahead and change that to 64. That's fine. You could even write 64 over here. I always like to leave it as 8 squared rather than 64, and here's my reason. When we do this, you'll always follow this pattern. This on the left hand side is x plus 8 quantity squared. Here are the key places. It's always this variable, it's always this sign, And if you leave it as 8 squared rather than changing it to 64, it's that number. That's where these three things come from. Okay, so if you want to change 8 squared to 64, that's fine. It still works, but I just find it to be maybe a little bit simpler just to leave it as 8 squared on the left and change it to 64 on the right. Now, we can use our square roots method. So x plus 8 is equal to plus or minus the square root of 81. So x plus 8 equals plus or minus 9. So x is negative 8 plus or minus 9. Now what we go ahead and do when we have numbers like this, we know negative 8 plus 9 is 1 and negative 8 minus 9 is negative 17. Those are our two solutions. All right, we're going to do the same thing on number 5, x squared minus 2x. Now our b value is 2, so that tells me I need to add 1 squared, which, yes, I know that's 1, to each side. Okay, now the right side is always pretty simple, just add the two numbers together. The left side, you're always creating that perfect square trinomial. In this case, it's x, it's this symbol, and it's this number, so x minus 1 quantity squared. Square root of both sides gives us x minus 1 equals plus or minus 5. So x equals 1 plus or minus 5. And again, we'd go ahead and clean that up. 1 plus 5 is 6. 1 minus 5 is negative 4. So we have two solutions to that equation. So let's move forward and look at some others. The numbers don't always work out perfectly pretty like we have seen on the last couple of examples. As a matter of fact, I would argue that most of the time they don't end up with those nice values, like nice perfect squares on the right hand side. So sometimes we get a problem like this where really we need to move that 50 to the other side. And you notice I left a little space. And I left a little space because I'm going to add half of b squared. Half of b is 9. Square it and you get 81. So I'm adding that to both sides. Now we've been through this process, so I'm not going to talk about it in too much detail, but this is x minus 9 quantity squared. Negative 50 plus 81 gives me 31. So x minus 9 is equal to plus or minus the square root of 31. Now our job is to solve for x, so we want to go ahead and add 9 to both sides, and I would just write it this way: 9 plus or minus the square root of 31. All right, why don't you do this? Pause the video, do number 7 on your own. All right, welcome back. You can see what I've done on number 7. Now the one thing we ran into that was perhaps a little annoying to you on this problem was the fact that the b term was odd. So we'd have to add 9 halves squared to each side. Now if you tried to do this with decimals, I mean, it can work, but I think that doing fractions tends to be a lot nicer. So I always just leave it as 9 halves squared, which we know is 81 fourths. If you add 3 to that, that would be 12 fourths. And you can follow along what I've done here. In the end, I know square root of 4 is 2, so I went ahead and pulled that out and just made it negative 9 plus or minus the square root of 93 all over 2, or you can separate it like I've written it here. All right, so I know that the numbers weren't quite as nice on that one, but again, it's the same process. All right, let's look at number 8. We're going to run into something a little different here, so I want to go through this one together. X squared minus 6x, I'm going to leave a little space, is equal to negative 16. Okay, so I need to do half of b, which is 3, and add it, square it, and add it to both sides. So that would be 3 squared here and 9 here. All right, so I'm going to have x minus 3 quantity squared is equal to negative 7. So x minus 3 equals plus or minus the square root of a negative number. We have run into this situation a few times, and we know that when you end up with a square root of a negative number, that's problematic when you're trying to solve algebraic equations. So we would just simply say that there are no real solutions. moving on to our last slide of today's notes, we're going to use Desmos to estimate the values for which f of x equals 3, and then use completing the square to confirm the results. Now, we haven't actually done Desmos for anything other than finding x-intercept. So this is a little bit different, but I'm going to show you how. So what I've done is I've gone ahead and graphed f of x is equal to x squared minus 6x minus 5. Pretty simple to graph that, right? Now our job is to find where does that graph have a value of 3. So I can just type it in as f of x equals 3. And what I'm looking for here is where do the two graphs intersect. Now, and I probably should point this out, I don't technically have to write f of x. If I preferred, I could just put y equals 3, same thing. And for some of you that might make more sense, so that would be fine. And you can see we have two intersections here. All right, two intersections. And I'm going to go ahead and copy those over to my notes real quick. And there they are. So you can see the two intersections. Those are going to be our two solutions. But let's go ahead and confirm algebraically what we just did graphically. So x squared minus 6x minus 5, we said it's equal to 3, so we're going to do equals 3. So I'm going to use completing the square, x squared minus 6x. I'm going to leave a little space, and I'm going to add that 5 to both sides. And the reason I left some space, as you could probably predict, is we're going to complete the square. So we're going to do a plus 3 squared over here, and that's the same as 9, right? So this is x minus 3, quantity squared, equals 17. So x minus 3 is equal to plus or minus the square root of 17, and x equals 3 plus or minus the square root of 17. Now, if you use your calculators, what you'll find is when you punch in 3 plus the square root of 17, you get 7.12. We'll just approximate it there. And if you do 3 minus the square root of 17, you get negative 1.12. Pretty cool stuff. All right, folks, I hope this lesson makes sense to you, and we'll have some time to work next time we have class. So if you have questions, bring them, and you guys have a spectacular day.